Hello everyone. Today we are going to discuss about the biodegradable plastics. As we know, nowadays we are having facing lots of problem with the accumulation of plastic, synthetic plastic which is accumulated or which is accumulating in our environment. So scientists are trying to make the plastic which will be biodegradable in nature. As the plastic which we are using right now is petroleum derived plastics. They are having many advantages, like they are having high stability, due to which they are very durable in nature, and they are suitable for many types of mechanical and thermal properties. They are suitable for mechanical and thermal properties. Even we can say that the synthetic plastic has now become an integral part of our day-to-day life. Even we can say that it is impossible to live without the plastic. What we wear, even up to the cars, what we use, everywhere we are having the plastics. Even if we will talk about the food, when we are going out and getting packed food, so the containers are made of plastics. The credit cards which we are using for any cash, for any delivery of cash or anything like that, we are using credit cards which is made up of plastic. Even when we have to take medicines, those medicines are also packed in the plastic bottles, and many plastic ziploc bags are there. Even we can in simply say when we are born and when we are dead. When we are born, we use diapers which are having many components of plastics, and at the late stage of the life we are also using adult diapers there. So every part of our life is influenced by the use of the synthetic plastic. As I said that it is difficult to decompose these plastics as they are synthetic in nature. We are not having any natural enzyme which will be able to degrade this synthetic plastic. If we will go for incineration of these plastics produce hazardous gas, due to which there is a rise in the temperature, so global warm that leads to the global warming. Even these synthetic chemicals are having many harmful chemicals such as hydrogen cyanide, which can be formed from acrylonitrile based plastic. Even these plastics, when they are altered by having some additives like pigments, coatings, and filters in it, that time they become horrible. In matter like we can't go for the recycling of these processes. It's too for recycling. It's too labor intensive. Even we can say simply now, as we know that the need of plastic is growing day by day, so we have to curb this plastic usage, so that otherwise we will be having environmental pollution by this plastic. So as we know, this plastic is made from petroleum, which is non renewable sources. After few years there will be no petrol availability of the petroleum from which we will be able to make the petroleum, from which we will be able to make the plastic. So now we have to search for the other alternatives where we will be having another source for plastic. So these are bio-based polymers. These are bio-based polymers or biopolymers, which are produced biologically renewable resource, and these polymers sometimes are polymerized with the help of biological or chemical methods. These bio-based polymers are divided into or categorized into three main groups. First group is the biochemosynthetic polymer, means it involves bio as well as chemosynthetic polymer. Examples are polylactic acid, which is indicated by PLA, polybutylene succinate, polyvinyl alcohol, polyglycolic acid. These are the few examples which come under the biochemosynthetic polymer. The second class of polymer is the biosynthetic polymer, and the best example is the polyhydroxyalkylenate PHAs. These are naturally occurring polymers. And the third group of the bio-based polymers are the modified natural polymers. The polymers which are in the nature, like starch polymer are there, or cellulose derivatives are there, which can be used for making of the biopolymers. So if we will talk about the biochemosynthetic polymer, these monomers are synthesized by the biological agent and then they are chemically polymerized. Monomers are synthesized by the biological agent and the polymers are synthesized by chemical agents. Like we are having best example of this is polylactic acid. This polylactic acid monomer is produced by the microbial fermentation. Then with the use of different chemicals, the polymerization of this monomeric unit is converted to the PLA by using many metal catalysts. So now is naturally occurring polymer. The best example is the PHA. This PHA is a microbial storage polyester which is synthesized by many bacteria. And this PHA is the alternative source of plastic as compared to the petrochemical plastics. This PHA is completely biodegradable in nature. The importance of this PHA is it is the completely biodegradable in nature. If we will talk about the long-term benefits of this PHA, by using this BHA, we will not be having accumulation of plastic in the nature as it is biodegradable, due to which there will be no global warming or environmental pollution, and we will not be dependent on the fossil fuels. As this PHA is produced by the bacteria, so it will be cheaply available and renewable carbon feedback in the nature. For this PHA, for the growing or the accumulation of PHA in the microorganisms, we can use different carbon source, and it has been observed among different carbon sources that plant oils have play or they are attractive carbon source for large scale production of PHA. So out of which we can say we are having different plant oils are there, out of which palm oil is the best source for the growing of microorganisms which are responsible for the production of the PHA. The palm oil is the world's most efficient producer oil. This oil is mostly produced in Malaysia and Indonesia, from where they export this palm oil to the world. If we are having higher demand of PHA, then we have to expand these oil palm plantation, where we will be having high number of palm oil trees. Then from these palm oil trees we will extract the palm oils, which will be used as a carbon source. As I said, this PHA is completely biologically made process. They are having different monomers are produced, then subsequently they are polymerized within in the bacterial cell. Means monomers are formed biologically and the polymerization takes place within in the bacterial cells. So If we will say that the polymer, it's not like mother like we all the polymers which are in present in the nature are biodegradable. We are having some polymers such as crystalline PLA, cellulose derivatives, and polyethers are present in the nature, but these are not biodegradable in nature. So we can say all the polymers which are naturally occurring are not biodegradable. Like we are having other polymers, natural polymers like starch is there, proteins are there, but we are having enzymes which are able to degrade these polymers. Like for starch we are having amylases, or for proteins we are having proteinases. The polymers which possess different functional groups such as esters, anhydrides, carbates, amides, urea can be also hydrolyzed by using different enzymes. So the PHA undergo hydrolysis of ester bonds, which is catalyzed by the intracellular or the extracellular PHA depolymerase enzyme. This extracellular depolymerase enzymes are secreted by many fungi and many bacterial species. So what they do, this extracellular depolymerase enzyme break down this PHA, as this is a polymer, so it will be high in molecular weight. These bacteria and fungi are able to degrade this PHA into the low molecular weight product that can be assimilated and metabolized by different organisms. If we will, these organisms can degrade this PHA aerobically as well as anaerobically. If we will talk about the final product of aerobic process, that leads to the formation of carbon dioxide and the water. So under aerobic condition, PHA is degraded into the carbon dioxide and water. Under anaerobic conditions, methane is formed. If we will dump this PHA film into the soil, then it has been observed that within in the 2 months of time, these films or these PHAs are completely degraded, as there will be higher as this PHA will be directly exposed to the soil microorganism, where they are able to go for the breakdown of this PHA. This PHA are having many monomers. Like we are having different examples like Homo Polymers. The example is the poly 3 hydroxylbutyrate P3HB can be hydrolytically degraded to a normal blood constituent in humans. So this can be used, this can be have different applications in biomaterials. And however, because of the high crystallinity and the absence of PHA depolymerase in humans, so there will be slow in the degradation process. The another PHA is the poly 3 hydroxybutyrate CO3 hydroxyvalate with the low crystallinity than the P3HB. So and there will be higher rate of degradation. These homopolymers are used for different tissue engineering processes. Like in case of we are having artificial tissues or bone tissues are there, or artificial bones are there. Even epithelial tissues are made from these biopolymers. If we will talk about the polyhydroxyalkanoates, alkalonate PHAs, these are biopolyesters which include various hydroxyl alkanoates, which includes different hydroxyalkanoates. 73 different genera, which includes many gram positive and gram negative bacteria, are able to synthesize this PHA. So if I will talk about how much PHA is produced, 90% weight of dry weight of the organism, they are producing maximum up to the 90% of their dry weight. It has been observed when we grow these organisms under the laboratory condition, under the nutritional stress condition, where we have provided these organisms with the limited source of nitrogen, phosphorus, magnesium, oxygen, but there is excess amount of carbon in the medium. So we can say it's an unfavorable condition. Under that condition, when we are having stress, nutrient stress, but excess of carbon source, the bacterial cell are able to assimilate or accumulate carbon source, which are then biochemically processed into the 3 hydroxyl 3-hydroxyalcoholonic acid, 3-hydroxyalcoholonic acid, 3HA monomer units, and this monomer units are polymerized then into the higher molecular weight water soluble PHA molecules. So these molecules, if we will see these PHA molecules under the phase contrast microscope, they are granular inclusion present in the microbial cytoplasm with the diameter of 0.2 to 0.5 micrometers. And these polymers resembles with the polyethylene or polypropylene in nature. Due to this, these PHAs are used as a bioplastics. There is another monomer unit, that is P3HB. This P3HB is produced by the Bacillus megaterium, and this P3BHB is regarded as the soul of PHA monomeric unit. This is regarded as the soul of the PHA monomeric unit. The other monomers which are present in this PHA are 3-hydroxyl valerate, 3HV, or 3-hydroxyl xanthonate, 3HHX are also there. It has been observed that 150 different types of monomers are present in these PHA molecules. So if we will talk about the bacterial PHA, this bacterial PHA is divided into three main categories. Depends on the number of the carbon atom in the monomeric unit. Means जितने monomeric unit present होंगे उस हिसाब से bacterial PHA को क्या किया जाता है, classify. There are simply three types: short chain length, medium chain length, and the combination or the mixture of the small chain length and the medium chain length. When the carbon atom is ranging from 3 to 5, they are included in the small chain length PHAs. When the carbon atom is ranging from 6 to 14 carbon atoms, then they are included in the medium chain length. And the small and the intermediate, which is a combination of small chain length and the carbon chain length, are from 3 to 14 per monomer. If I will talk about the Homo Polymer 3PH, which is widely studied, is small chain. This is a small chain length polymer, and its core polymers contain 3HV, 3HHX, or 4HB monomers. In nature, small chain length PHAs contain mainly 3HB units, or medium chain length PHAs contain 3-hydroxyoctanate monomers. They contain 3-hydroxyoctanate monomers, 3OH, and 3-hydroxyl deconate, 3HD, as a monomer units. So With the help of these many copolymers, these biopolymers are highly flexible, or we can say these biopolymers are more flexible and tougher plastic than the plastic which is obtained from the plastics. So scientists are working more on it so that there will be more and more production of biopolymers which are degradable in the nature as well. As this is the summary what we have discussed till now. So if we will say, there are three different types of biopolymers. First is the chemosynthetic polymer, second is the biosynthetic polymer, third is the modified natural polymers. So if we'll talk about the biochemosynthetic polymer, these are biologically synthesized in a monomeric, and with the help of chemicals they are getting polymerized, and the example is PLA, polylactic acid, polybutylene succinate, and they are biodegradable by hydrolytically degradable except crystalline poly- polylactic acid. These are not degradable in the nature. So second example is their biosynthetic polymers. These biosynthetic polymers are first monomers. They are formed in the cell, and within in the cell they are forming the polymers, and the example is the poly 3 hydroxyl butyrate. So there are enzymes present many which are able to degrade these biosynthetic polymers. And the modified natural polymers, they are chemically modified, or chemical modification of natural polymers takes place, like in case we have seen the starch polymer or the derivatives of the cellulose. So there is also, and they are degraded by the different enzymatic processes.